Okay, so this is the 9th video in the critical path analysis NS3. And in this video, we're going to be looking at float times. So a float time is essentially the amount of time an activity can be delayed without affecting other network activities. So the float time is calculated by this equation here. It's calculated by minusing the EST from the LST. And if you have a look in the example down here, activity C would have a float time of 8 here minus 8. So that would equal 0. And if you have a look at activity D, you would minus the LST and the EST. And so 9 minus 6 would have a float time of 3. Now what this means is that activity C has no flexibility around its starting time. It must start on time, otherwise it will affect other activities in the project. Whereas activity D has a float of 3, which means it can be delayed or it can just be floated or waited for 3 without affecting any of the other activities in the network or in the project. So that's what float times are. Now let's go to the next slide. And so float times are critically important because they help us find the critical path. So if you have a look at the example below, all activities that have a float of 0 are critical activities and will be on the critical path. So the critical path here is highlighted in red, and it shows that at the starting point, 0 minus 0 is 0. At A, 8 minus 8 is 0. C, 9 minus 9 is 0. 12 minus 12 is 0. 14 minus 14 is 0. And 15 minus 15 is 0. Whereas if you see what activities lie on this blue line, 11 minus 9 is 2. 9 minus 6 is 3. And 3 minus 0 is 3. So the ones in blue do not lie on the critical path, but the ones in red do lie on the critical path. And so if you are in an exam and you have been asked to find the critical path, you would simply you would calculate the LST and EST for each edge, each activity, and then you would minus the LST and the EST to find the float times, and any float times that would equal 0, you would highlight that edge. And so the markers can clearly see what the critical path is and what activities lie on that critical path. So in this example, A, C, E, G, and H, A, C, E, G, and H are all critical activities. So the critical path is simply the order of activities that cannot be delayed without affecting the completion time. So in a critical path, nothing can go wrong, and it's critical that it gets completed on time. So an example might be you're building a house and you need the wood first to build the house, but you can wait a bit to get the paint, whereas you need the nails straight away to join the pieces of wood together. So that getting the nails and getting the wood would be the critical activities, whereas getting the paint can wait a bit, or it could just float around in the air until you need it. So that's essentially what the critical path is. And the minimum time is just the overall completion time or the last EST value. And if we have a look at this network diagram here, the last EST value is 15. And so the minimum completion time for this network, the earliest it can get done, is 15. Now, let's have a look at this example. and we have been asked to find the critical path. And so what we're going to do is we're going to go ahead and calculate the float times for each activity. So if you have a look here, 10 minus 10 would give us 0. 12 minus 10 would give us 2. 12 minus 10 would give us 2. So those two would not be on the critical path. And the start 0, 0 would give us 0. 14 minus 12 would not give us 0. 19 minus 19 would give us 0. 22 minus 22 would give us 0. 26 and 26 would give us 0. 28 and 28 would give us 0. 25 and 24 would give us 1. So I'm going to cross that one out. 24 and 25 would give us 1. 15 and 16 would give us 1. So here 15 and 20 would give us 5. 15 and 15 would work. 15 and 15 would work. So now I'm going to go ahead and I'm going to highlight in yellow my critical path so that the markers can clearly see that I have got the critical path correct. So here we start at 0, 0, we go, oh, let's undo that. Here we're starting at 0, 0. Oh, why is it always doing that? Okay, let's try again, undo. So here we start at 0, 0 and we go across. Then we can see that we're going up for B with 0, 0. Then we can see that we're going down here for H for the 15. And then you can see that we are going down here for the 19, across to the 22, up to the next 0, 26, and across to 28. So that would be our critical path. And the activities that would lie on this critical path would be activity A, activity B, activity H, I, L, and M. So these activities here in red are our critical activities because they lie on the critical path because their float times are 0, and that is how you would find the critical path from a network diagram. Now I'm going to rub this out and we can go on to our next example. Okay. So here we go. We've been given an activity chart and we have been asked to draw the network diagram, calculate the EST and LST for each activity, then calculate the float times and find the critical path. So I'm going to go to the next slide and we have a little bit more room here to draw our network diagram. Okay, so let's have a look at our activity chart and we have a look at the ones that have no immediate predecessors because that means they are the start edges. And if you look here, A and B both have no immediate predecessors. So that means they are the start edges. Oh, I don't want to do it in yellow, I want to do it in black. Okay, so here's going to be my A edge. And before I draw my B edge, I'm just going to quickly scan ahead of my activity chart. And I can see here that C and D both have immediate predecessors of A and B. So instead of drawing my B line out here like this and then doing a dummy up here for C and D to come out of, which you could do, I'm just going to go ahead and just draw a line like this to indicate my B. And I'm going to put my next node in there. and then label your edges so you know which one is which. So that's what I'm going to do now. And this one here is my A. Oops. This one here is A, and it has a weight of 6. And this one here is my B, and it has a weight of 9. Okay, now that we've done that, you can look at or you could cross those two out because we know we've done those, A and B. Now we have to do C, and we know that C is coming out of A and B node. So we can draw C like this. And we know that D also comes out of that node. So while we're there, we can draw D. Now we're going to label these edges. So this one here was C, and it had a float time of 8. So put that in. And this one here was D, and that one had a float time of 7. All right, now we can go ahead and look at our next activity, which is E. And activity E comes out of activity D, so we can put it like this. But again, if you look ahead, which I highly recommend you get in the habit of doing, activity F comes out of C and E. And so if the node for C is up here and activity E is going to come out here, we may as well just draw activity E to meet with activity C up here, because then we can easily do F coming out there. So now I'm going to go ahead and put in my nodes, my node, and label each edge so I know which one is which. This one here we said was going to be our E with 10. And this one here is going to be our F with a weight of 12. And then I'm going to type in the start node and type in the finish node. Oh, let's make that a bit bigger. There we go. Now that we've got our network diagram drawn, we need to go in and we need to put in the EST and the LST for each activity. And we have no dummies in our network diagram, so it should be fairly easy. So I'm going to get my draw. I'm going to do the earliest start time in green and the latest start time in blue, just so I don't have to draw a box, but there is my distinction between them. Here equals my EST. All right, so I'm just going to draw that a bit better. There we go. Okay, so we can go in and put in the EST for A. So here we can do, well, we'll do a box here. Oops, I'm not doing boxes. So the earliest start time at the start would obviously be 0. And for this edge here, it would be 0 too. Over here, we would have a 0, 0. We would have our B edge coming to this node. And remember, when you want EST, you want the highest possible value. And so here we would have 9, and we would also have 9 down there. Then when you get to this here, we would have 9 plus 7, which is 16. When we come up here, you would have 16 plus 10. Remember, we want the highest node. We don't want 9 plus 8 because that would be less than 16 plus 10. So when we come up here, we now have 26. And 26 plus 12 would give us 38. Right, now I'm going to go and do my next color in blue. So this will be the latest start time. And remember, you want the lower value. Okay, so our latest start time is just the same as the earliest for the finish. Then 38 minus 12 would give us 26. 26 minus 10 would give us 16. Then we can do 16 minus 7 would give us 9 for here. 26 minus 8 would give us, is it 18? Yes, it's 18. 18. Then we can do 9 here minus 9 there to give us 0. And then we'd have 18 minus 6 to give us, oh no, we can do 9 because that's the node. So 9 minus 6 would give us 3. Because remember, when you get to here, you can use this box up there or this one down here, and you want to use the smallest one. So that's why we use the 9 minus 6 to 3, not the 18 minus 6. Okay, so now we've done that, we can have a look and we can do our critical path. I'm going to do our critical path in yellow. And so if we have a look, 0 minus 0 is 0. 9 minus 9 is 0. So I can know that this line along here would be our critical path. I would know that 16 minus 16 would be 0. So that would come down here. 26 minus 26 would be 0, so it would go up there. And 38 minus 38 would be 0. So that would be the critical path for our project. And finally, we can label the critical path. So the critical path would equal, is going to be in red, so critical path would equal, we have B going to D, going to E, and then F. So these are all the activities, B, D, E, and F, that lie on the critical path because we calculated their float times as 0. And what is the minimum time required to complete the project? The minimum time to complete the project will be in pink here. And it's the earliest start time. So it would just be 38. 38. So that is how you would draw your network diagram, how you'd calculate the EST and the LST. Remember, for the EST, which is in green, you want the highest possible value, and for the LST in blue, you want the lowest possible value. So remember, if at this node here, you had 2 options, take the option that is the lowest. And so you'd have 9 minus 6 to get 3. The float times are the LST minus the EST, and the float times that is 0 are on the critical path. There we go.